So I'm going to start with adding and subtracting fractions. And, you know, fractions is one of those math topics when I talk about fractions, people get really confused. Yet we use fractions a lot in real life. So I am going to do the operation part of fractions, sort of the procedures, but I'm going to try to talk a little bit about, you know, fraction, number sense, and fraction operation, so it's not just a procedure. So estimate and then add. So the reason I have students estimate is, I mean, we know that if we have 2/3, we sort of know what 2/3 of a cup looks like. It's more than half. And then we have 3/4. We know 3/4 of a cup is almost full. You know, if I break it into 4 parts, I take 3 of those parts. And so if I have more than a half and almost full, then I know my number must be 1 and some more. So I want them to estimate first so that when I show them the procedure and they get the answer, they can determine if the answer makes sense. So now I'm going to show you the procedure that you might use. It's not the only thing you can do. You can model this as well, but in this case I'm going to show the procedures. And so, as funny as it is, I learned to write mine vertically like this. It's not something that you have to do. I can just write right underneath if I want, but I'm going to write it vertically just because when I do the next, some of the other ones with mixed numbers, I like to have it vertically. So the first thing I'm going to do is ask, what is a common denominator that I can use? Because when I'm adding fractions, I need common denominators. And in this case, you need to know something about your factors and your multiples, and in this case, both 3 and 4 are factors of 12, or some people say 3 and 4 go into 12, but anyway, they're factors of 12. And so I'm going to say, I want to change these to 12ths. And so just like earlier today, or the other day when you saw the video, I talked about equivalent fractions. That's what I'm doing now. And so to get an equivalent fraction, I have to say, well, I started with a 3 and I want to end up with a 12 as a denominator. So I'm going to say 3 times what gives me 12? 3 times 4 gives me 12. So 2 times 4 gives me 8. And so whatever I do to the denominator, I want to do to the numerator. But let me show you this as well. Remember that when I multiply by 1, when I multiply anything by 1, I keep the same value. And so 4 over 4 is like multiplying that fraction by 1. So that's why I get an equivalent fraction. So 2/3 times 4 over 4 gives me 8 over 12. Okay, so let's try the next one. 4 times what gives me 12? 4 times 3. So if I multiply the denominator by 3, I want to do the same to the numerator. Why? Who can remember? I just talked about it. Why is it okay to multiply the numerator and the denominator by the same number? Yes, because I'm multiplying by 1. So if I multiply by 1, then I have the same value. So 4 times 3 on the denominator gives me 12, and so 3 times 3 gives me 9. And so now I have the same denominator. When I have like things, then I can add them. So in this case, I have 8/12 and 9/12. Remember the other day when I talked about the size of the fraction? Well, these are 12ths. And if I have the same size pieces, I can just add how many of those pieces I have. So I have 8/12 and 9/12. So altogether I have 17/12. If I have 17/12, I know I have more than 1 because 12/12 is equal to 1. So I could say this. I could say, let's see, I have 12/12 plus 5 more 12s. Let's see if that's true. If I have 12/12 plus 5 more 12s, I have 17/12. So that's, in other words, as saying I have 1 whole and 5 12s. there's all different kinds of ways of doing this. Some people say 17 divided by 12 is 1 with 5 left over, 5 remainder, and they put the 5 on the numerator. But remember, when you do that, you're really making it procedural. Whereas if you just think about, I have 12 twelfths that equals a whole, then I have 5 left over. I wanted to show you also, when I have 17 twelfths, we call that an improper fraction. The numerator is larger than the denominator. So when we have that, it's nice to also show students, why is it that I have 1 and 5 twelfths? Yes, we talked about it here, but some kids might need to see it. And so here I broke this up into 12 sections. My sections won't be perfect. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I broke this up into 12. And the reason I did that was to show you, if I shade in 17 twelfths, well, I'm going to shade this whole thing in because I already said it was 12 twelfths. So there's my 12 twelfths plus 5 more. So 12, 13, 14, 15, 16, 17. 17 what? Well, we just said they're called twelfths. So 17 twelfths is the same as 1 whole and 5 twelfths. So some students might need to see that as well. All right, now let's do 1 4/5 plus 2 1/3. I wanted to do some that had mixed numbers. So again, I'm going to write it vertically. I don't have to. 1 4/5 plus 2 1/3. So again, I need to find common denominators. So in this case, my common denominator between a 5, let me make that a little better, between a 5 and a 3 is going to be 15. Now, when I'm adding these, because I'm just adding, I could add the whole numbers, and then I could add the fractions, and then I can add them back together if I need to. And that's how I'm going to do it. Some people have other procedures that they like to use. Some people like to change everything into improper fractions. I don't think that's necessary. So I'm going to do it this way. So again, if I multiply the numerator and denominator by the same number, I'm multiplying by 1, and that's okay to do. So here I'm going to say 3 times what gives me 15? 3 times 5. Well, if I multiply the denominator by 5, I could also multiply the numerator by 5. So 1 times 5 gives me 5. 3 times 5 is 15. 1 times 5 is 5. And then on the numerator, on the top fraction, 5 times 3 gives me 15. So 4 times 3 gives me 12. And in both cases, remember, I'm multiplying by 1. And that's okay to do. So now that I have those, I have the same denominator, I have a common denominator, now I can just add the numerators. I have 12 fifteenths and 5 fifteenths. So altogether I have 17 fifteenths. Oh, I must like that number 17. And then I have 1 plus 2 is 3. So I have 3 whole. Let's see. Okay. So in the same way I did here with the 17 twelfths, with the improper fraction, I'm going to do here 17 fifteenths, right? So I already have 3 wholes, and then I have another 15 fifteenths here. So that makes another whole. So that is equal to 15 fifteenths plus 2 fifteenths. That's what this is equal to. So now all together, I'm going to have 4, because 5, oops, that equals 1 and 2 fifteenths. So 3 plus 1 is 4 and 2 fifteenths. All right, so remember, this part is just here. The 3 is still a whole number by itself, okay? All right, so let's do one subtraction, okay? I wanted to do a subtraction just as a reminder. Okay, so 5 3/5 minus 2 3/4. The same thing for subtraction. I need a common denominator, and in this case, Since my denominators are 5 and 4, my common denominator will be 20. So it just so happens that, 4 times 5 is also 20. 3 times 5 is 15. That will not always happen. Sometimes you'll have a common denominator if I have a 4 and an 8, right? 4 actually is a factor of 8. So 8 would be my common denominator. So you don't always have to multiply the two denominators, but you do have to find a common denominator. If you multiply the two denominators, you will always find a common denominator because a factor times a factor makes a common denominator, okay? So let's multiply. 4 times 5 gives me 20, so 3 times 5 gives me 15. 5 times 4 gives me 20, so 3 times 4 gives me 12. So I did this on purpose. I wanted to have to borrow, okay? Borrow using a fraction. Okay, so I say 12 minus 15. Well, I can't take 15 away from 12. I don't have enough. So I have to borrow from the whole number. So if I borrow 1 whole, and I only have 4 there, 1 whole is the same as what? Well, since I'm working with denominator of 20, why would I want to change that? So that's like saying I have plus 20 20ths, right? Look, I took 1 whole from there, and I want to give it to this fraction, 20 20ths. So now my new fraction is 32 20ths minus 15 20ths. Now I can do it. Looks like a lot of work. It's a lot of thinking, but it makes sense, right? Not just a procedure, but borrowing from the 1 whole, and 1 whole is the same as 20 20ths. Add that to the 12 20s you already have, and you have 32 20s. Now I can take away the 15. And I end up with 32 minus 15 is 17 20ths plus 4 minus 2. 4 minus 2 is 2. So I end up with 2 and 17 20ths. Okay? So that ends the first part of this. Next week, you'll be looking at multiplication and division.